Hello again. Today we're going to see what is oxidation and reduction when it comes into terms with chemistry. Well, the first thing we have to see is what are the oxidation numbers. That is something we already know, and we may have mentioned it with a different name, like valence, for example, and see which is the oxidation number, oxidation state of the different ions. Okay, we're talking about oxidation states. We're talking about ions of all the elements that come from the first group in the periodic table. They all have an oxidation state of +1. To the elements in group 2, well, that's very easy. You can guess it. It's number 2. Oxidation state is +2. We can see the charges on top of the element are 2 positive charges, so the oxidation state is +2. Make sure that you make sure that you make the point on where the symbol and the number are. When we're talking about the number of charges, is first the number and then the charge, and when we're talking about the oxidation state, is first the charge and then the number. Okay, carry on, and we go to the following element or the following group. 3 plus makes oxidation state +3. If we go to the anions, those with negative charges, okay, we can see we still follow the same rule. This is a very important point, or a very important element, that is the oxygen that we will use a lot. Okay. Finally, if we have fluoride. Fluoride has a negative charge, so the oxidation state of fluoride is -1. Rules. The rules we are going to use to know which is the oxidation number of the different elements, or even the different ions that are formed by more than one atom. Okay, so in simple ions, we have the oxidation state that is the same as the charge on the ion. That's very clear. That's what we have seen. This is a very important point as well. If the atoms are in their elemental state, the oxidation state is always 0. They don't have extra charges, positive or negative, so the oxidation state is 0. If we have a compound that have no extra charges, positive or negative, so the compound is completely, let's say, closed. All the oxidation states of the different elements that form it, the total number of oxidation states is going to be 0. And when we have ions that are formed by more than one atom, this is polyatomic ions. For example, here we have the sulfate ions. It has 1 sulfur atom, 4 oxygen atoms, and 2 negative charges. So this is a sulfate anion. In this case, the total of all oxidation states is not going to be 0 like in a normal compound, but the total number will have to add. The final result must be the charge on the ion. How does this apply to a normal element, or a normal compound, the ones we have seen, like for example potassium bromide, like this one? Potassium has an oxidation state of +1, and we know this is a compound with no extra charges, so the total sum of the charge of the potassium and the charge of the bromine must be equal to 0. The total sum must be equal to 0. In that case, just by simple calculation, we will know that the oxidation state on top of bromine is -1. If we do it with carbon dioxide, we know, this is again something we said before, and that is very important that we keep in mind, that the oxygen is going to have a -2 charge, but we have 2 of them, so we have to write 2 of them. Okay, and this is a compound. The total number of the compound must be 0. Okay, so the oxidation state of carbon -4 must be equal to 0. Well, that's easy again, because the oxidation state of carbon +4. Okay. If we have another example like this, calcium chloride, the oxidation state of calcium is +2, and we have to calculate what is the oxidation state of chlorine in this molecule. That this is +2, and we know that the oxidation state of chlorine must be multiplied by 2, because we have 2 chlorine atoms. Again, because this is a compound with no extra positive or negative charges, the total amount of the total sum of oxidation states must be 0. We have 2 for the calcium, and we have 2 times the oxidation state of chlorine is -1. Okay, so 2 times -1 makes -2, and +2 makes 0. There. What happens when we have a polyatomic anion? Okay, here we have to be careful, because we have here the charge of the ion. So in that case, the compound is not going to have a total sum of 0. The total sum will have to be equal to -3. We have -3, and we have 4 atoms of oxygen, each one with an oxidation state of -2. That makes, okay, and the oxidation state of phosphorus must be something that when added to the -8 of the oxygen atoms, in the end a -3. So the oxidation state of phosphorus -8, that comes from here, gives us a -3. Okay, and that -3, remember, comes from here. Not difficult. The oxidation state is +5. Okay. Well, when we apply that to the different compounds and substances that we have in chemistry, and say what is the oxidation state of the different atoms, in this case, just following that rule, the copper must have an oxidation state multiplied by 2, that added to the oxidation state of oxygen. Oxidation state of oxygen is -2, so that will give us that we're working with copper 1 oxide. This is exactly the rule that we're following when we're practicing formulation, and that is why we practice formulation instead of having the copper 1 oxide. We have CuO. We have the oxidation state. Remember that the oxidation state of oxygen is always -2. So when we add the oxidation state of copper, must be 0. That means that we are working with copper 2 oxide. When we do it with other different atoms and other different compounds, we can see that the iron 2 oxide comes when the oxidation state of iron is +2, that the iron 3 oxide is written Fe2O3, so the oxidation states of iron 3 times 2 and the oxygen 3 times 2 compensate each other. And when we do it with manganese oxide, well, we have to take into account that the oxidation state is going to be +4. So thank you, that's all so far.